Hi, my name is Thomas Kim. Today I'm going to explain efficient permutation algorithm, how to enumerate permutation efficiently. I am 51 years old. I will be 51 years old on January 25th next year. Then that means I have lived 51 years now. And a man of my age usually have lots of things to share with other peoples, with younger generations. In a sense, I'm very rich. What I mean very rich, I have lots of things to share with the younger generations. Those experiences I built for last 30 years doing my work and my research or my study, doing things like that, I found quite some new things from my perspective. My own perspective, I found some algorithms that's worthwhile to share with others. And most of those algorithms I found by myself alone. But later, I found most of the algorithm I found actually was already published by someone else. I mean, some other people in different world, across the age. Some of the algorithms I found was already published 100 years ago, or longer sometimes. But however, I think I have quite a lot to share with others. This algorithm, efficient permutation algorithm, actually I found February 22nd, 2017. I mean February this year, I found this algorithm and I implemented and I made a short YouTube video about this algorithm. But because at that time I didn't explain through whiteboard, I just wrote algorithm and implementation I demonstrated. But in this video, I want to explain the theory behind. If you say, even if I explain algorithm, C++ algorithm clearly, if you don't understand the theory behind how this algorithm works, without understanding the theory, the algorithm would not be much useful, would not be much worth. So I will explain the theory behind this algorithm and also how to implement it today. It's a little bit difficult. In fact, it's a little bit difficult. But once you understand the fundamentals, even if you forgot the algorithm, you can still implement it. Let's get started. Suppose we have 5 elements, a set of 5 elements E, for example. We are going to choose the 3 elements and we enumerate like this. The first step is 1, 2, 3. We are selecting 1, 2, 3 elements. The next step is 1, 2, 0, 1, then 3, 0, 1, 4. Then we used all 3 elements now. Then 0, 2, 1, 0, 2, 3, 0, 2, 4. Now we are starting 0, 3, 1, 0, 3, 2, 0, 3, 4. Now starting with number 4, 0, 4, 1, 0, 4, 2, 0, 4, 3, 0. We are now, we cannot do this now. We are moving to 1, 1, 2, 3. Now 0, in this case, this disappeared, right? We don't have 0 here. Now 1, 2, 4 we used. Then we goes this way. This is permutation. We are saying out of 4 elements, out of 5, we are choosing 3. How many different ways? It is computed like this: 5, 4, 3 ways we can make such kind of list. It will be such numbers like it will be 60. So because we started with 0, it should be the last one would be 59. Okay. This is permutation. We are going to make a function like this. Okay. We are going to make a function. It will be called ENUM, enumerate permute, like this. We are giving number 5, for example, 5 elements. We are selecting 3. Then we are giving index. For example, if we put 0, for example, then this function will return 0, 1, 2, like this. If we give, for example, 11, if we give it 11, then it will give this number, 1, 4, 3. This is enumeration, permutation enumeration. Okay, we are going to make such functions, and I am going to explain how to make such functions. Suppose we have three numbers, a set of 3 numbers, for example, E equals 0, 1, 2. We have 3 numbers, a set with 3 elements. We are choosing 2, for example, 0, 1, 2, 3, 4, 5, 6. We are choosing 2 elements. First, 0, 1. Second, 0, 2. Then this is third. We choose 1, 1, 1, 0, 1, 2. Now we choose 3 and 2, 2, then 0, 2, then 1. We are done. What it means is that we are from 3 elements, we are choosing 2. If we see this number will be labeled MTH. So if we see this, there are 2 ones, 2 zeros, 2 ones, 2 twos, like this. Because we choose 2, we label it P and R here. N is 3 elements. 2 is, we are choosing 2 elements, like this. If we see it carefully, for example, if we are given M's, for example, 3, for example, I will try with this one, M's. For example, 3, then we first evaluate this number 3. We divide like this. 3 divide P 2 1. Because why we are doing this is because if we are going to select the first element of our set 0, 1, 2. To choose the first element, we understand that we have among 3 elements. This is M's, m's. From m's, this is m's. For any number, if we are given m's, then we divide this number 3 with p to 1. For p to 1, p to 2p1 is 2. Because when we choose one number, then we have two elements. From two elements, we have to choose one. Because in this set, we are going to choose two elements, right? From this set, if we choose one element, this is the first element, then we are left two elements. So this can be, this number can represent it n minus 1, r minus 1, because we choose one. Okay? So if we are given number m's, then we choose, we divide m's, divide n minus 1, r1, like this, for example. And we take the quotient. The quotient in this case, 3 divided 2, the quotient is 1, right? So this number becomes 1. We are taking the quotient, and the remainder is 1. Okay? So since this is 1, means this is index 0, okay? This is index 1, then we remove it. And we put result set, we put like this, 1. If this quotient is 1, then we remove 0, 1 first element from this set, then we have v1 equals 1. Now we have e. Now e becomes like this, 0, 2, like this, right? Now the remainder is 1 here. Now we are dividing, we are taking quotient again. I would say this is S0, S1 will be computed like this. 1 divide P 1 0, like this. Because this is n, because this is the next P21, P1, P0, like this. P0 equals 1. So it becomes 1 and 1. Okay? If S1 is 1, it means this is 0, 1. Index is 0, index is 1. So we are choosing this element and we put here. So it becomes 1, 2. Okay? If we see this is the element we are seeking. I will explain it once again. Now, for example, we are given 5 elements and we are choosing 3 elements, and this is m's, this is m's, we label it m's. For example, if we are given m's such as 11, for example, 11, we are trying to find this number like this. Let's see how we find it. First, because this is 5 elements, P, 5, 3, we are computing not this number, 4, P2. We are computing this number. Because this effectively equals 5 times 4, P2. Five times 4 P2 is this number actually. So we divide this with this term, 11, so we make it as 0, as not. 11 divide P42. Okay? So if it is, because this number 4 P2 equals 4, 3, this is 12. So it gives 12 over 11, it gives 0. Say S0 is S0, S0 is 0. Okay, we make remainder m's. The remainder, we now set the remainder becomes 11, right? 11 divided by 12, remainder is 11. So in this case, we are trying this again. Now S1 will be 11 divided 3, 2, like this. Now if we compute this 11, this is 3, 4, 2, 3, 1, then it becomes 3, right? Then S1 will be 11, 3, 9, 2. So S1 becomes 3, and MTH, it becomes remainder. Remainder will be 2, right? So S0, S1 becomes 3, and remainder is 2. Now we are applying this rule once again. S0, S2, S1, 2. Now M2 here. Now we are choosing this. The next one is 2P0. 2P0. It means 2 over 1 is 2. So S2 equals 2. So the first step is we find this set. So how we are going to use this set? We first have to find this set, like this algorithm. If we find this set, we are computing like this. We are starting with 11, for example. First, we use this number 0. The index 0 is number 0. So we make V. We put 0 number here. Okay. Then we delete it. So we don't need it. Okay. Now the number is 3. Then we erase 0, 1, 2, 3. Then we select this number 4. Okay. So we delete it. Now we have number 2. 0, 1, 2. We have 3. This is the number we are seeking for. 0, 4, 3. To make your understanding concrete, I will try another number, okay? So let's say MTH, M is number 13. Now we try with 13, this number. So 13. We compute S0 like this, S0, the first element, 13 over, this is 5P3. We now try 4P2, like this. Then 13 times 4 times 3, 13, 12, 1. Quotient is 1. Now remainder, we have remainder. Now we bring remainder. If the remainder divided 13 divided by 12 is remainder is 1. Now we try S1 again here. Now M1. Now 3P1 like this. Then 1, 3 is 0. Okay. Now remainder, we bring remainder here from previous equation. Remainder, we bring remainder. Remainder is 1. Now we try, this is S1. Now we try S2. This value here, MTH, we put 2, P0, 1, 2p0 is 1, so it is 1. If we collect these values, we make a set like this: 1, 0, 1. So that if we are given, for example, if we are given ENUM, ENUM permu, for example, 5, 3, for example, M's. If we are given numbers like this, the very first step is we have to make this set. Okay? Then using this set with this number, the very first we have to make is set like this. For example, this is 13. Then we can generate this set with using this method. Using this set, we can make V. It returns V. V can be chosen like this. So with this set, we select number 1 and not 1. The first one would be 0, 1, 2, 3, 4. This is index, okay? Index. The number 1 becomes here index. Index becomes 1. We delete it. So 1. Okay? So we remove it. Now we have 0. From this set again, 0, 1, 2, 3. 0 means this 0. Okay? So we delete. We put 0 here. Now we delete it. From this number 1, from 0, 1, 2, this is index 1. We delete 3. We bring 3. Then it deletes. This is the number we are seeking for. 1, 0, 3. So I will make it as an algorithm like this. I will express for any number m's. So we can say I will denote it like this: as 0 will be computed, like m's, mth divided by this n minus 1, r minus 1, right? P n minus 1, r minus 1. The quotient, okay? Then after this we said mth is remainder divided by this number. We say is remainder. We can calculate remainder like this. Remainder n1 pr1 like this. So if we try this number again and again, then we have m0, m1, m2, m3 like this. Okay, using this relationship, we can compute until r becomes 0. Okay, until r becomes 0. Until this term becomes 0. That means if this term becomes 0, means r minus 1 equals 0, r equals 1. Okay? When it start here, we start with, when we are given number 3, we are starting 2. So it can be from I would say k. Okay? I will say k. Okay, and the k starts with r minus 1, and it ends 2, 1, like this. It starts with r minus 1 and ends with r1 with 1, because if we put it here, it becomes 0. So we compute this way. if we got this set, I would say S0, S1, S2, S say we have R elements 0, 1, 2, we say R minus 1. Okay, R minus 1, then we are using this as index of this set. 0, 1, 2, 3, 4. We are using this as index. So V will be like this. V, elements of V will be the index S says index, this is 0, 1, 2, 3, 4 like this. So index will be, this will be index, for example. This is index of this element, S0, S1. So here this is not correct. We have to put like this. V is a index. Okay? So V becomes V0, Vi becomes like this. Vi. Zeroth element. If this I is 0, S0, then it becomes index of E. Okay? But each time if we apply this rule, each element is this element. Element should be deleted. For example, this is S. This should be 0, 1, 2, 3, 4, for example. Then this index the element will be Si. This number should be deleted like this. When we move to this vector, this set, the result set, the corresponding element should be removed. I hope you understand. Now, I will summarize the algorithm and I will move to my laptop and implement this in C++ code. Before I move, I will explain here a little bit. If we are given like we are returning std, we are returning vector vector, vector, for example int. We are returning vector like this. enum permu here n r m's, for example like this. In this example, it can be 5, 3, for example this one 11. If we are given, we are making functions like this, then at the very first step is compute this set. This set will be vector. Actually, you can say vector int. You say s for example. Then how many elements we need? We need 3 elements, 3 set. So we can say R like this. We are making 3 elements. Actually, we don't need this. Okay, we don't need this. Then we are creating this vector S set, index set. I would say index set S0, S1, S2, SR minus 1. Like this. We are using this algorithm as I explained before. So using this algorithm, we create S like this. I will say get slot. I would say slot, or I can say index. Here we are passing what we need. We need N, R, and M. So this will be 5, 3, 11. After this function gets flat, we'll build a set S like this. S0, S1, S2. For example, if 11 is given, this number would be, if 11 is given, this number would be 5, 0, 0, 4, 3. 0, 0, 4, 3. Ah, 0, 3, 2. It becomes 0, 3, 2. Zero, 3, 2. We will, this function will return 0, 3 to this set. Then we are doing loop for like this. We are doing loop here for index I, for example. From this set, we use V. Of course, we need to declare his vector V. This is return value, and I will say L. L is this set, E set. Or I can just say E set, E. Here we have to initialize this set. Initialize E. E is vector. We initialize like this. 0, 1, 2, 3, 4. Like this. We initialize like this. Then here we are doing loop like this. V. You can say push, or we can just say push, or in place back. In place back. We are putting this set elements. How? This is E. We say E. We are using this as index. S. I. So using this set, this element S0, S1, S2, we are using this as index of this function, this vector. This is index. Okay? Then after putting this, we have to delete corresponding element. We have to remove that element. For example, if it is choose 0, for example 0, we have to remove this. How we do this? Here we calculate the index to delete. ITR, for example, ITR is index E begin plus SI. This is index. We are calculating index. Then we delete E. Erase ITR. This way we can erase vector elements. So if it loops back, this moves like this, and this element we are using this index, then we fill this vector. This is then we can return B. This is basic implementation. Now I will move to my desktop. Then I will code all these things in C++ code. If you haven't watched my video about how to enumerate combination or subset, how to construct subsets in C++, please watch this video. I created a empty solution, fast enumerate permutation. Now I will include IO stream, and I need to include S stream. I need to include vector, and exception, and C std int. We are creating a function npr permutation, number of permutations, template, type name t permu, tn tr, like this. While, let me see, I don't need this one. If r greater than or equal to 0 and r less than or equal to n, unsigned, I would say uint max t bar 1 put t I equals to 0, I less than r, then plus I bar times n minus I. Now we are return t bar. Else if r equals 0 and n greater than 0, or r equals 0 and n equals 0, this is 0 case, then return 1. Else this is error case, std or string stream os out of range in permu, and r then throw std out of range or str. Okay, I do say t rlt bar do like this. And you don't need this. Return bar t bar. Okay. Sorry. are false. Actually, we don't need this. Break. Return by. Okay, we made permutation. Let's test anti std cout permu 5 3 3. It should give us 3 factorial and one more 0. One, 2, we are testing this function. Okay. I think it's correct. It's correct. Let's check. Yes, this is correct. Let's move on. This is correct. Now we are creating a function. Now let's try it. think it's not the error. Okay, fixed. Now we are creating index vector, template, type name, std, vector. We are creating index set t get index tn tr tn. Here std vector t s. We are creating r and npr. We need permutation r, but we have to make it like this, and also like this. T npr I say nr n minus r npr 0 equals t1 compute npr. Here for size t I equals 1 should be size t less than r plus I. Yeah, you can say npr I permutation t and r plus I t I. We can also say npr t and r plus I times npr I minus 1. We can do the same thing. This is actually faster. This method is faster. Then here we computed npr for size t I equals 1 I size t r plus I. Now we are computing I minus 1 equals m's npr r minus 1 m's. This is remainder npr r minus I so size s size t r minus 1 equal m's or we can say this should be I, or we can say like this I r it becomes 0 is 1 is 1, so you can say like this. or I think it's better. So return S. Compute index set or S S0 S0 S1 S2 here. We are computing now. Template type name T std vector T enum permu tn tr t index. You can see instead of index it is m's. Okay, here std vector s get index n r m's. Build set S0 S1. About this, please watch previous part of the video. std vector T. We are creating E is element E set. So in this case n elements. You see size T for size T I equals 0 size T n plus I E I equals T I. We are initializing E will be something like this 0 1 2 n minus 1, something like this. Then std vector T. B is the result we are looking for. It should be R. You have to be careful about this size T. You have to do like this. Then for size T I equal 0, or I can say K. It doesn't matter. Size T R plus I bi. This part is tricky. S I. This is key element. This is key. As I explained in the a few minutes ago, auto ITR, we are getting index E begin plus we have to do size T here S I. Then erase. We are erasing element. Erase ITR like this. Assign move element move S
element from E to B. See? Delete, remove, the ice element from the set E. Okay, these two lines. Now we are returning B. Return B. Okay. Now we will pick some. We'll remove them. Here, we are saying enum permu. We are testing 5. We say 3 3 3 3 0, for example. Just to build, we'll say 5 3 5 3 11. Now compile. T. Now compile again. Okay. Now let's run. Control F5. This is correct value. Now we are testing it. I will say unsigned and int max t for big integer, int max tr, int max t npr, like this. We declared AJN again, cd cout to kit enter 0 and std scene r npr permu and r for int max t k less than npr. You can say mmax m's less than npr plus m's. Here and r m's. Get m's permutation of npr. I would say m's. Okay. Now let's run it. Let's build it first. We have some warnings we need to fix. Okay, here. If n equals 0 and r equals 0, return 0. Else here, go to again. Now argument. It should be size t. Okay. size t like this. Let's check more. Here it should be size t, size t, and it also should be size t. This should be size t. Now build once again. Okay. Now 3, 3 means we choose 3 elements from the set with the 3 distinctive elements. This is 3 factorial. First, 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, 2, 0, 1, 2, 1, 0. Yes, this is the last element, the first element. Now we are trying 5, 3. We are choosing the elements like this. I will make it one thing more here to make it pretty. Here I would say okay, I will put it here. Here std set w, sorry, 3. Let's run it. Why code is let me see. W okay. 11s. This is correct. Okay, it works fine. So now let's try with 7, 4. Wow. 8. 8. Wow. I guess it takes too long. I will close it. Okay, this way we can implement permutation. If we want to get specific permutation, using this we can get specific permutations. I mean m's permutation. We don't need to enumerate all. I will disable it and I will show you another example. No, I will use it. Then, for example, we have a set. I will fix it to 5, for example. No, I will fix it for 3. 3, for example. I will 2. Okay. Then we don't need this. And we don't need to go to again this one, we don't need. And we are creating a set std vector, and we are creating string std string. So here names. We are creating like apple, banana, then cherry. Okay. So we have 3 here. We are permuting like this. 4 size t I 0 I n plus I here std cout names I would say fruits evaluate fruits size t we need to get a set here std vector and t max t idx enum permu and rms like this. Then here idx I. Okay. Now let's see. std cout std and there here we display std cout ems. Okay, let's run. About what's causing the problem is 3r npr not n, it should be r. Here apple, banana, apple, cherry, apple, banana, apple, banana, cherry. We are enumerating all. We can select all like this. 3. No, we can add more. Cherry, tango, and A, B, C, D, E. Echo, 1, 2, 3, 4, 5. Okay, let's say 5. Now we can enumerate all. Wow, beautiful. Apple, banana, cherry, tango, echo. Apple, banana, cherry, echo, tango. Apple, banana, tango, cherry, echo. So this is the beauty of permutation. Thank you for watching. If you like my video, please subscribe and give me like button. You can download source code in the comment section below. Thank you for watching.